Good morning. So in today's class, we will see the curl operation. So last class, we saw what is a gradient operation as well as a divergence operation in all the three coordinates, Cartesian, cylindrical, as well as spherical. So examination point of view, you just need to understand what is the formula in these three coordinates as well as what is the physical interpretation. So you may get a 3-mark or 5-mark question, which is talking about the physical interpretation. So physical interpretation means I have given you some notes and some figures, right? Like how that is the amount of flux coming out, like those things. So that is the physical interpretation. And derivation also, small derivation is there. You can just understand and keep that in your mind. Suppose if it is asked means you can write. So complete derivation is not required. Just the how it is coming you can understand. So today we will see what is curl operation and then these two relationship like del dot del cross A, that is divergence of curl of a vector, and then curl of divergence of a scalar. What happens? So we'll just see these two relationship. And next class we will do problems from gradient, divergence, and curl. Okay. So curl of a vector means, so just like you have studied gradient and divergence, curl provides the measure of the amount of rotation. So curl is all about rotation. So curl and the Malayalam meaning also is related to rotation only. What does it mean by curl? Sorry. So the curl provides the measure of the amount of rotation or angular momentum of a vector around the point. Okay, so you have one point and how the amount of rotation is denoted by the physical interpretation is the amount of rotation you have a vector, let that be an electric field or a magnetic field. So curl denotes the amount of rotation of that vector around a particular point. So around rotation or angular momentum is omega r or omega, that is 2 pi f. So amount of rotation. So for example, you can see that here there is a vector, maybe it's an electric field. So it's going in a straight line. So there is no rotational motion here because all the velocities are same. So if the velocities are same means there will not be any rotation. So here curl is equal to 0. That is here del cross, if the vector is E, del cross E equal to 0. And here curl is equal to 0. And due to the same velocity everywhere, the velocity is same means there is no rotation motion. So the amount of rotation or angular momentum around the point is 0. But in this case, you have one vector E1, E2, E3. So due to difference in velocities, there will be a rotating effect, and that is called curl. So the difference in rotation means like it has the chance of going rotating, right? If there is one point here, then due to this difference, it will be rotating. So that's why we say here the curl is not 0. Here del cross E is not equal to 0. So here we can say that there is a curl present here. Similarly, in case of rotation motion, here also curl is there. Curl is rotating, right? And if we are considering it with respect to our axis, x, y, and z axis, and if you consider like this, then we have v1 here, v2 here, v3 here. So here the overall curl is not 0 because here we have the rotational motion. So curl means it provides the measure of the amount of rotation or angular momentum. So example is electrostatic field. So this is actually del cross F, that is irrotation or conservation. So electrostatic field is irrotation. So that we will study in the next module. Don't worry about that. So due to the same velocity, the curl is equal to 0. So is it clear what is the physical interpretation of curl? Okay, so now we'll move on to the equation form. So the component of curl of a vector in the direction of a unit vector an is the ratio of the line integral of the vector. So f dot dl. Similarly, you have seen in the case of divergence also here. F dot dl by delta s. There we were talking about the volume because the amount of flux coming out of the volume was divergence. Here what we are talking, It is the ratio of the line integral of the vector around a closed contour to the area enclosed by the contour as the area tends to 0. There it was all about the volume tending to 0. So the component of curl of a vector in the direction of the unit vector an. So when you're asked about the physical interpretation, you should write what we have seen in the last slide, as well as these things you should write. So the component of curl of a vector in the direction of the unit vector an, that is an is a normal vector, is the ratio of the line integral of the vector around a closed contour. It is the line integral of the vector around a closed contour to the area enclosed by the contour as the area tender is curl of is equal to limit delta s tending to 0 integral f dot dl by delta s along the direction n. So this is the physical meaning, where direction of the contour is given by right hand corkscrew rule or right hand thumb rule. നിങ്ങൾ മെഷീൻസിൽ പഠിക്കുന്ന അതേ റൈറ്റ് ഹാൻഡ് തമ്പ് റൂൾ വെച്ചിട്ടായിരിക്കും നിങ്ങൾ ഇതിന്റെ ഡയറക്ഷൻ അറിയാൻ പറ്റുന്നത്. That is how it is rotation motion direction, whether clockwise or anti-clockwise എന്ന് അറിയാൻ പറ്റുന്നത് is based on right hand thumb rule. Right hand thumb rule എന്ന് പറയുന്നത് electromagnetic theory point of view is not important for you. You can just write down if at all you are asked about the physical interpretation of curl. So what curl, it denotes the amount of rotation of the vector, and then it is denoted by del cross f. So it is del cross f. All these things you should know. Del cross f. So if the vector field which you are considering, need not say it is electric field. So we'll study about electric field in the next class only. So let it be a vector f, and if it has a different velocity, then we will get a rotation field, and that is one case. Then if it is along, it is already rotating, means its curl is not equal to 0. So same velocity means the curl will not be 0. And this is del cross f is equal to 0 means we say it is irrotational or conservative. We see in the next module. This is application of curl. Then we say that curl of actually means limit delta s tending to 0 integral closed integral f dot dl by del s along the vector an. So that is the physical meaning of curl, physical interpretation of curl. Clear or not? Okay. Then we'll consider a vector. So here also I am not going into the detailed derivation. Consider vector f, which is f1 a1 plus f2 a2 plus f3 a3. So here also we have our curvilinear coordinates, and you know that the value of h1 h2 and h3 along the Cartesian, cylindrical and spherical coordinates we have already derived. So last 3 classes we are dealing with this. So h1 will be h1 h2 and h3 will be 1 in rectangular, h1 h2. So these values 1 rho and 1 r sin theta. So these values are familiar for you. So let's use these values and find out what is curl. Okay. So with regarding here also I haven't written the derivation. So I have directly taken the equation. So what actually comes is, I'll just write, because the derivation is not important, that's why I didn't give, but just I'll write. So when we, just like in the previous divergence class, when we do this closed integral along all the 6 sides, like last class we have seen, we need to do integral f dot dl along all the 6 sides and then add it up. So what finally we get in terms of curvilinear coordinates is 1 by h1 h2 h3 into h1 a1 h2 a2 into h3 a3 and dou by dou u1 dou by dou u2 dou by dou u3, then f1 h1 f2 h2 and f3 h3. Okay. So this is what we get, and then f1, f2, and f3 is the coordinate of along the each axis, right? Whether it is rectangular, cylindrical, or spherical, because all the 3 coordinates have 3 axes. And h1, h2, h3, you know what is the value for each coordinate. So based on that, you will get this. Or else you can, normally what we do is we directly give this equation and then we move to the problem. We say what is curl, then we say what is its physical interpretation, then we directly move on to this equation. But if at all, sometimes if something like if physical interpretation is asked for 10 marks, then you may write like in terms of curvilinear coordinates and all, and then if you write means you will get 10 marks. So, so just for understanding, keep this in mind. Then you just need to substitute the value of h1, h2, and h3 for each coordinates. Then you will get what is del cross f in each coordinate, so that you need not by heart all these things. So del cross f will be ax, ay, az. That is the cross product we are talking about. Dou by dou x, dou by dou by dou. So say the coordinates will come here. When it comes to cylindrical, we have rho in the second. The second axis will have rho here, and regarding the spherical means the second axis will be r. Here it will be r sine theta, and here it will be r, and here it will be r sine theta. Okay, so that will be the changes. Is it clear? Okay, then the divergence of curl. So this derivations it can come for university exam. So series exam I'll ask you only problems. So assignment questions can work out. So these things it can come for your university exam. So del dot del cross A, that is divergence of curl. Cross product matrix. If you are given a matrix, you know how to take the cross product. School level you remember how to take the cross product? AX this into this minus this into this plus column, column. You know that how to take cross product? Cross product okay. When we do problem, I will show you once. When we do the problem, I will show you once. So del dot del cross A equal to 0. So we'll consider one vector. Let A is equal to ax plus ay plus az. Then del cross A, this is how we take the cross product. We have studied in lower classes. So ax, ay, az, we write it directly. Dou by dou x, dou by dou y, dou by dou z. Then the coordinate will be right here, ax, ay. If we vector, we take the cross product of that. So this is how we take. Already the particular. That is already ax, coordinates ax, ay, az. So if you're talking about ax means it is dou by dou y of, so ax on a dou by dou y of az minus dou by dou z of ay. Dou by dou z of ay into ax plus same way. Ay so an arrow column, that means column, first and third column consider. That means dou by dou x of az minus dou by dou x of az into y. Same way, az these two terms, dou by dou x of ay, dou by dou x of ay minus dou by dou f is cross product. You have engineering entrance cross product very important. Physics use it. Same cross product. So I'll show you once. For those who are not remembering, I will just show you once when we do the problem. So we will name gx. So dou by dou y of a is set. This much term. We'll name this much term as gx. Okay. So this will be gx. This will be gx. For calculation comfort, we will mention this as gx, and this will be gz. Then gx plus gy ay plus gz az. That is equation number 1. Then we do what? Then we do the gradient operation, del dot. So not gradient, divergence, right? We'll do the div operation, that is del dot a. So dou by dou x of gx by dou by dou y of gy plus dou by dou z of gz. Under gz, substitute we will get dou by dou x of this much value, that is dou by this much value we get. Then ഇതിപ്പം double derivative ആയിട്ട് കിട്ടും. So that I will write down. So what we get is dou square Az divided by dou x dou y minus dou square Ay divided by dou x dou z plus dou square Ax divided by dou y dou z minus dou square Az divided by dou y dou x plus dou square Ay into dou z dou x minus dou square Ax divided by dou z dou y is equal to എന്ത് വരും? സെയിം ടേംസ് വന്നില്ലേ? ഡോ സ്കോർ എ ഇസഡ് ഡോ എക്സ് ഡോ വൈ, ഡോ സ്കോർ എ ഇസഡ് ഡോ എക്സ് ഡോ വൈ, and dou square ay cancel ആയി, ഇത് cancel ആയി. So we proved that it is equal to 0. Derivation മനസ്സിലായോ? How we proved that del dot del cross a equal to 0. So ഇവിടെ വന്നു കഴിഞ്ഞാൽ നമുക്ക് ഡബിൾ ഡെറിവേറ്റീവ് എടുക്കേണ്ട കേസ് വരും. അങ്ങനെ സെയിം ടേംസ് വരുമ്പോൾ we can cancel it out. So you should know how to take the cross product. That is very important. Okay, then one more relation we have, which is del cross del dot v equal to 0. So first of all, we'll take a vector. So you know that we know that the proof will be like, so we know that del v and the another, it is dou v by dou x plus dou v by dou y plus dou v by dou z. Gradient എടുക്കുന്നത് curl of gradient of a scalar. Then we do the cross product del cross del v. ഈ ഒരു ഇത്രയും ടേമിന്റെ ക്രോസ് പ്രോഡക്റ്റ് എടുക്കുക. So ax ay and az divided by dou by dou x dou by dou y dou by so it will be dou by dou z, then dou v by dou x into dou v by dou y into dou v by dou z. അതായത് കമ്മില്ല, കാരണം സ്കെയിലാർ ആവുമ്പം നമ്മൾ ഗ്രേഡിയന്റ് ഓഫ് എ സ്കെയിലാർ, അപ്പം സ്കെയിലാർ ആവുമ്പം നമുക്ക് ഇപ്പം യൂണിറ്റ് വെക്ടർ ഒന്നും ഇവിടെ വരില്ല, പക്ഷെ ദെൻ ഡെൽ ക്രോസ് ഡെൽ വി ആണ് നമ്മൾ ചെയ്യുന്നത്. സോ എ എക്സ് എ വൈ ഇസഡ്, സോ ഡോ ബൈ ഡോ എക്സ് ഡോ ബൈ ഡോ വൈ ഡോ ബൈ ഡോ ഇസഡ്, ദെൻ ഇവിടുത്തെ പർട്ടിക്കുലർ ടേംസ് എന്താണ്? ഡോ വി ബൈ ഡോ എക്സ് തന്നെയാണ്. അപ്പൊ ഇതിന്റെ ക്രോസ് ആണ് നമ്മൾ എടുക്കുന്നത്. ദാറ്റ്സ് വൈ വി ഗോട്ട് ഡോ വി ബൈ ഡോ എക്സ് ഹിയർ. ഈ മെട്രിക്സ് എഴുതിയത് നിങ്ങൾക്ക് മനസ്സിലായോ? Del cross del v, then just same way ഓരോ ടേംസും എടുത്ത് ക്രോസ് പ്രോഡക്റ്റ്. So if you know how to take the cross product, this is easy. ഇവിടെയും സെയിം വേ ക്യാൻസൽ ആയി പോകും. ഡോ സ്ക്വയർ വി ബൈ ഡോ വൈ ഡോ ഇസഡ് മൈനസ് ഡോ സ്ക്വയർ വി ബൈ ഡോ ഇസഡ് ഡോ വൈ into ax plus dou square v by dou z dou x minus dou square v by dou x dou z ay plus dou square v by dou x dou y minus dou square v by dou y dou x into az. So you can see same terms on dou square v by dou y dou z minus dou square v by dou z dou y. നോക്കുമ്പോൾ സെയിം ടേംസ് തന്നെയാണ്, ഇതെല്ലാം സെയിം ആണ്. That means we can take it equal to 0. Is it clear? So in today's class we have seen what is curl, the physical interpretation, and then how we derive it. Like how we finally arrive at this equation. So you can just write it is based on curvilinear coordinates. So we have 6 sides, and then these 6 sides we take the integral value. This integral value we take, and we finally arrive at this equation. So in this equation, H1, H2, H3, you know the values. So if you substitute, you will get del cross F in and del cross F in Cartesian, cylindrical, and spherical coordinates. And then we have two relationships. There is a divergence of curl of a vector, that is del dot del cross A equal to 0. So we proved that what it is. And then we have another relationship, that is curl of gradient of a scalar, that is del cross del V, del dot V. So that also we proved, and we proved that it is equal to 0. Okay.